Hello, I am Chris from the Great Brick Lab, and welcome to Big Robot Week 5. Today, we're going to go over some of the other projects that I have learned about in the last couple of weeks here on our Discord channel. People have been sharing information. And with me, I have Amanda, of course, and I also have Justin Merrill. Welcome, Amanda and Justin.
Thank you. Thank you for
So,
having me.
so today we're going to be going over. Justin's joined us because he's got a project in development, and we're going to get some Q&A with him. So if you have questions, be sure to put those in the chat, and we'll see if he is willing or able to answer the questions. And of course, we're always willing and able to answer any questions that we can as well. So what this project is, the code name is Big Robot, but essentially it's an open source Lego AI sorting machine that we're building. You can certainly go back and watch the previous live videos and some of the other shorts that are on my channel to help you get familiar with the project. You can join our Discord, which is in the scroll at the bottom if you want to join and help us develop. We always need, we're getting some good track on the AI, how to do photos, how to crop photos and stuff like that. There's really good conversations going on in the Discord right now. But some of the delivery of how we get that from the machine, and how we kind of consistently take pictures from different locations and kind of crowdsource that. It was lots of good conversation around that. Also in the scroll, you'll see some information about a Give, Send, Go / Lego AI. Any funds that are given to the Lego AI Give, Send, Go source there are going to be used to help fund the open source portion of this project. I will not use any of those funds to build the machine that my company, Great Brick Lab, will use itself. That is being funded by myself, with Amanda as the main designer and builder of that machine. So if you want to give, please give. And then hopefully at the end of this project, which I think we're hitting to a 12 or 14 week project, so just about at the halfway point, depending how you look at that. So maybe next week we'll call it the halfway point. The end of the project will hopefully have a prototype that we can use to sort Lego. But there's some logistics that we're trying to figure out, and how to get that machine up and running. Amanda's doing some good things. So I think what we'll do is we'll save the updates on our machine until the end of today's live, and then Amanda will go over the machine that she's been doing with our machine. So with that introduction, I think what I will do is, Justin, we can talk about your machine here. I do have a video, but before we do that, Justin, why don't you take a moment to introduce yourself and tell people who you are?
Yeah, so my name is Justin Merrill. I'm currently down in the Charlotte area. Recently moved down there, enjoying the weather moved there from Pennsylvania. So if anyone's ever made that transition, they know how nice it is to get to some warmer weather. Background, a little bit of everything. Started up a makerspace. So anyone who's involved with a makerspace knows the great skill sets that people have there, and like to explore and tinker with everything. And right now, primarily a freelance software developer. And the project that we'll look at that I've recently posted, myself and a partner, Aaron Butler, are working on that, with Aaron doing a lot of the mechanical and my contributions from the software side.
Mm-hmm. Okay, so thanks for telling us that. So tell me what you want your machine to accomplish.
So right now we're just trying to sort Lego, play with some AI, and see how far we can push it to eliminate the entropy of Lego in an automated way. So lots of engineering challenges to overcome from electrical, mechanical standpoint, and especially software. So it's been quite the learning experience, and challenges that we definitely didn't see or didn't expect the scale of, now that we're really vested in this project.
Mm-hmm.
So kind of long-term goal with trying to monetize it in a way, playing around with different options there. Our first thought is to do kind of like a sorting as a service, and also we'll see once we demonstrate that it can sort, that you put a bunch of Legos in and stored Legos come out. We'll see what sort of feedback we get from the communities.
Cool. Yeah, and and me running a bricklink store for the last 6 years, I have learned, and there's an abundance of bulk Lego
Hmm.
located in continental U.S. There's no shortage of Lego whatsoever. It just depends on how much you're willing to spend and how much you source. And over time, I've definitely grown the collection of Lego that we have. So let's do this. I will share the video of this is a video of Justin's machine that is posted. I don't know how do they get access to this video? Is there a good way to get access to this video? Somebody wanted to watch it.
I think I just posted the Bricklink Facebook group. I I'll be in the Discord, and I could share, or you can share a link
Okay.
in Discord to
And
this video.
and this video actually also has a link to the video as well. I just didn't know where they can get updates to your videos if they wanted to. So look for it on Facebook, but maybe later we'll get another video of that.
Mhm.
So let's watch the video. And as we're watching the video, I'm going to pause it at certain points. Amanda and I might have a couple questions about your specific functions of your machine. Grant you, there's no audio for the machine. I can hear the audio, but I know the audio is not playing through. So essentially, how are you feeding the Lego up? Okay, so it's a pusher.
Yeah, yeah. So that's the first stage, a little hopper pusher, and then kind of similar to what I've seen in your guys' machine, a little vibratory feeder there to line them all up, and the output should be one Lego at a time here.
So we've had a challenge with our vibrator V channel where they're not actually vibrating down; they're actually going in any direction. Is that true, Amanda? How are we dealing with that?
Yeah, so our vibrator currently, if you put a round piece in the end of it, like if you put the round piece on its side, it will just spin around, and if another piece doesn't come along to push it, it doesn't fall off at all. So,
Okay.
somebody on Discord proposed that was because I was using an offset weight on a motor to vibrate it, and I need to use some sort of electromagnet instead that lurches the whole thing forward. But I don't know how you build that.
Okay. Justin, have you had any problems like that with your machine?
Yeah, so it seems like one of those problems that would be like super easy to solve and intuitive, and then you go and you design something and it just doesn't work as expected, and you have so many variables that you wouldn't think have such a big impact. So I don't know if in this shot or maybe a frame or two before, right in the middle, the round piece is essentially electromagnet being this a speaker. So
This
we
right
have,
here?
yep, right underneath that black part is just like a kind of like a subwoofer. So that is our version of an electromagnet. If I'm sure you guys have been looking up inspiration all over the internet, so you've seen those vibratory bowls where the parts just kind of magically like float and move along.
Mm-hmm.
That's
Yeah.
part of our inspiration there, and those do use a electromagnet to move things along, and that's what we're using to drive here, just a speaker. But then playing around with like frequency and amplitude, and everything has a different outcome of how the Legos behave. So right now, I think we just have it at incline, vibrating at pretty low frequency, and they seem to be shuffling forward consistently for the most part now.
I have a question. What is this thing right here?
So to ensure that there's like spacing between the parts, we just have a little IR like brake beam, and when one part comes right off of if you go back a couple frames so you can see the end of that feeder, yep, right where your mouse was down there, there's another little like transmitter,
Mm-hmm.
and just creates a invisible beam, gets broken by Lego, and then that will pause the feed of the Legos.
So this is able to, is this being vibrated and it's still able to see the IR over here?
I think that sensor itself is on part of the stationary.
Oh, okay.
Yeah, both of those are stationary, and then the trough is floating above it.
Okay.
So
Okay.
this is where all the kind of the excitement happens. Kind of above off frame, we have right now just kind of your standard webcam, and looking down into a kind of light controlled area, trying to provide consistent lighting there. And you can see we have a mirror to get two views with one camera of the part. So instead of doing
interesting.
any kind of like isometric view, we're doing actually a top down view and then a side profile view of the part.
That's clever. Okay, so the part is past the camera.
Yep. So the camera's right above where your mouse is, looking down, and then that's where the photos are taken.
Okay, and these are just guides to get it to the middle.
Correct. Yep.
Okay. So I'm going to ask you a question. I'm curious about the belt system that you've got going on here.
Yeah. Nothing too special about that. When we're coming up with designs, we have throwing around all kind of ideas on like either flippers or like you guys did with the little pneumatics pushing it off. And so we got kind of longer runways so we could implement all of those if one of those designs became feasible. But right now we're just kind of using you'll see it down at the end of carousel. But the belt itself is just your kind of eBay special belt or eBay standard, I should say.
Okay.
Nothing too crazy there. Just white belt.
Was it the assembly included with the eBay purchase, this entire assembly, or just the belt?
More or less. Maybe a couple bolts that fall out during shipping, but I think it came pretty much assembled there. Didn't spend too much time on the conveyor part.
Okay.
Oh, so you didn't even have to splice the belt.
No, we didn't get the joy of that.
I have a recycled treadmill belt, so I had to splice it by hand, and that took a lot of time.
Mm-hmm.
The quality of the color on his belt is much better as well, but I don't know that you could put your cleats on there like you want.
Yeah, I might take the cleats off and give up on that idea.
Are the cleats not working out?
Well, for the camera pictures, they're really bad.
Is it okay? So this is where your carousel comes into play, and then a lot of your AI controlled dropping into a cup part.
Yep. So the camera will take a photo there, our AI model make a prediction, and then spin the carousel to the appropriate bucket for the prediction that was made. And yeah, so right now we're running it a little bit slower. The goal is to get it working consistently and then speed it up. Speed really comes towards the end as part of like refinement. There's nothing necessarily special about going faster. It just makes debugging more difficult. So right now we're just running everything kind of as slow as possible, working out all the kinks, and then we will speed things up as the bugs get worked out.
Yeah, a couple of things I noticed is that your spacing is really solid. That probably is a result of the IR being broken.
Yeah,
exactly. We were really pleased how that works with that.
And your push feeder, that's probably very prototype. You could probably increase the size of that very easily. Just make your hopper bigger.
Yeah. Yep. If we wanted to, if you had a lot of parts you wanted to pre-feed into there, you could make the hopper bigger, wider. If you need to push more through at a time, so lots of easy upgrades there.
So I know in a pre-conversation we were having, you were talking about the AI part of your project being kind of proprietary, and the API that you want to deliver to people. That's where you plan on kind of bringing in some monetary gain from your project. So I'm going to ask you a question about your AI. Is there anything that you are willing to share with us about your AI? Maybe even just how you built it or what you've learned about your AI so far?
Yeah, so I mean, of course, AI now kind of becoming more mainstream, and it's basically to the point that if you as an individual can see a picture and recognize what the part is, there should be a way for an AI trained model to do the same. So with that approach, it really comes down then to data collection and data processing, and that's where the monetization is important, just from the amount of the costs associated with the processing, the storage, and processing and storage can be the two big ones. But the backbone right now is TensorFlow. Nothing too crazy there. And then part of like down the line, as we get into moving things along more quickly, we'll probably go over to PyTorch just for speed. But yeah, right now our models are built in TensorFlow.
Okay. I have a couple more questions here, but I was going to hand it over to Amanda. And Amanda, what questions do you have about the machine? Anything at this point?
So about the AI, with TensorFlow, are there a lot of variables that you are able to tweak, just to make the model work better? Because we were looking into using Teachable machine, and it's just really simple. You just have pictures and you train it, and it just does things, and there's not a lot that you can change besides like number of epochs. So is there like anything important that you have to tweak in your AI that makes it work better?
Everything. And that was such a difficult, like as a software developer up to working with AI, there's always multiple ways to solve a problem, but then you start reading to AI and it's like, it's just brute force. There's nothing really necessarily special or like a correct way. You just have a bunch of data and then you're like brute forcing the answer that you want. So we are working with just the standard library from TensorFlow, but as you know, that has an infinite number of parameters that you can put in. You can create all sorts of model variations there. So to answer your question, there's everything. Everything can be tweaked. Everything we have tweaked and played around with, trying to find a combination of a model that does work consistently and works well across the variety of Lego parts.
Okay, so I have another question. So you mentioned before the live that you spent 8 months on your robot. At the beginning of that 8 months, did you have like prototype building happening, or was it all software first?
I'd say everything happened in parallel. So okay. You're kind of seeing like the end result of a lot of layers, and part of those layers that isn't necessarily evident in the machine itself is the data management side, because there is a lot of data that comes through, and it all really needs to be managed programmatically and efficiently. So if someone is there like downloading and uploading images or going through images, it's going to take forever to process hundreds of thousands of photos. So building a solid pipeline was definitely critical in the early stages. So that answers the question. There's a lot of behind the scenes work getting to this point. And then the machine itself, of course, you have the different elements like the hopper, the vibratory that has a little controller, the camera system is another controller, the carousel is another controller. So each of those has software built in, and then finally bringing all this and integration of all this together. So a lot of little layers that add up.
Yeah, so I know you're not the mechanical person, but so did you guys build multiple iterations of the hardware system throughout your process?
Yeah, definitely the vibratory one. Like I think probably ran into the same issues that you guys are, or sounds like you guys are running into, where it just doesn't act predictably. So that we had a lot of iterations. And then the hopper, the amount of, I think, torque on the motor was something that we were surprised in. We needed a little bit higher torqueier motor. So, and then once we got through those, surprisingly, the carousel came together so easily. We were shocked, but that's probably from all the iterations up to that point of everything else. We kind of knew what we were doing by then.
Yeah. So you also mentioned that you used an IR sensor. I kind of shy away from using lots of sensors because I know that, like from my experience, I haven't found any that are super reliable. Like they get dirty and they just like stop working. So what tips do you have on like keeping that working consistently? Is it like a fancy high dollar sensor or is it just like simple?
Yes, that one's pretty simple. Off the head, or off my head, top of my head, I don't know the part. I think you got it from DigiKey there. The whole mechanism has 2 sensors at the moment, and those are kind of placed. The one sensor is for the carousel, which is pretty important for positioning standpoint, and then the other sensor is that brake beam sensor. Maybe down the line we can eliminate both of those with pure camera or computer vision and just use cameras in place of those sensors. But for now, those are the 2 sensors we have. Nothing. They work pretty well and working pretty consistently there. Don't really have any complaints about the sensor.
Okay.
The environment of where the robot that Amanda's building is going to be in a somewhat industrial warehouse, definitely it would get dirty, and I think contamination on the IR sensor would be a problem.
Yeah, I could see that. I'm not sure if ours would be that susceptible to anything. I mean, the machine would have to be pretty dirty for it to start interfering.
I was thinking more like over a period of time, the machine is going to need some maintenance. So I could understand the challenges with an IR like that.
Well, I haven't used IR well, I wouldn't say that. I have used IR like range sensors and ultrasonic sensors, and it's just like you can't even touch the sensor without like wrecking it.
Oh, then I have to say this one is a little bit more forgiving than those, and we definitely went for simplicity up front. Try not to overcomplicate anything. So the sensor that we went for has a little bit of smarts built right in, and the output is just a on or off, like open or close. So it made integration really easy into the rest of the system.
And another question for you. So when you talk about sorting your parts, what are some of the objectives that you see? What are some of your objectives in a completed machine? What should it be able to do?
Ultimately, we want to sort down to the design and I guess element ID if you're taking into account the colors as well, but starting with the design down to design number, or down to design level. Initially, we're probably going to we have a model that can do a handful of those, and then we're starting to layer that with a categorical model that can separate your bricks, tiles, plates, and other high level categories. And I think the ultimate end goal is all of that plus the ability to tell between knockoff Legos and real Legos. That'll be a fun one to experiment with.
Yeah. So how many cups do you have in your carousel right now?
In the video we have 12, but that carousel can be it's built to be modular and stack, so we can add kind of layers or depth to it. And we'll be releasing a video here in the next month or so, hopefully with a couple more layers added to that to demonstrate that functionality.
Okay. Now, so your carousels, are they going to be limited by the size of those cups, or are they going to be able to feed to something else?
That I don't know. So once we have the kind of the AI working well, everything past that of how it actually gets into a storage container is open for interpretation and modification. So if we find that, especially in I guess the used Legos, there's going to be a couple that need a lot of storage.
Right.
So we can have maybe dedicated bulk bins for those. Yeah, all kind of options. After the point of the camera, it becomes pretty easy. It's the camera, the AI, that's the I think the core of the mechanism there.
Yeah, I agree. Because we've already mentioned once, we're running into a problem with our cleats and the camera identification. But the reason for the cleats is to kind of keep that Lego separated. So when the air blast hits it bounces off of it goes straight through the cleats and down into a channel that feeds a large hopper to store a lot of Lego parts. So you're farther along in your development than us. You've actually got your machine sorting parts, so that's pretty impressive. But like Amanda did bring up the point, it took you 8 months to get to this point on this machine. I'm also glad you mentioned that this is a demo speed that you're running at. Do you have a target goal of how many parts per second, or what are some of your goals on your speed?
I think minimal, maybe one every 2 seconds, and then from there we'd probably explore more like commercial speeds. Really having Legos fly through, but that would require more of a mechanical changes than what we have now. But theoretically, if we can run slow, we can always get a camera that takes images faster, and then a mechanism that sorts them out faster.
Okay. So a couple more questions, and then maybe we'll go on to showing the other project that I was made aware of overseas. Got 2 more questions here for you, Justin. So what have you learned so far that you want to share with everybody out there trying to build or think about a Lego sorting machine?
Oh man. Think definitely be prepared for things taking longer than you think they will, and kind of patient with the process there. And shortcuts really never play off in the long run. So taking your time, and even if you have like a section of code and you're excited to get it up and running, if you do it quickly and hard code stuff in, you'll pay for it later, because you'll forget that you hard coded something in then, and it'll come back to bite you. So if you're taking your time at the beginning, it pays off in the long run.
Okay. If there was any part that you could go back and redo now, what would that be?
Actually, I had an interesting conversation with my partner earlier today, and between the experience that we had up to this point, it seemed like that really helped us work through this project pretty efficiently. We really haven't run into any hiccups yet, so probably nothing that we would change at this stage. But we'll see how long that lasts.
Okay. So we will get to an update on our machine, but before we do that, I am going to share my screen one more time here. All right, so this is the Lego sorter, BSL Bricks. I think that's the name of the store. Commissioned a group of 4 students. This is a picture of the bulk that they have probably in their store. It says they buy brick as often as they can. They have these big containers all full of all kinds of bricks. This link up here is also in the description of the video. But let's open this up and get a look at their video here. Like I said, also you can get to the link here. But they're obviously doing a pre-sort. of their brick. So they've got all the bricks separated. And I wouldn't mind having one of those myself, more on industrial level. And they've got a hopper. So they used a conveyor belt, and they have also had some nice GUI software programmed for it as well. I noticed they didn't separate their tires from the wheels. It looks like they have multiple V channels. It went by so quick there in the video, but there was a picture of their camera system here. It looks like, I'm not sure what's going on here with the cameras.
Are they shining it through the plexiglass?
Yeah, I think they're looking through plexiglass in some way.
Yeah, I saw this video here recently, and if you scroll along that housing on the right, right there's kind of a box that once again contains the lighting, so you have consistent lighting.
Yeah, it looks like they have 3 webcams hooked up.
Yeah, I'm curious if they're just taking a prediction from all 3 and then averaging it out to get a best estimate, or what they're doing there.
And you had mentioned it before, but they're obviously using paddles. I was concerned about paddles because of the speed that you can get, but if it worked this fast all day long and the paddles consistently did their work, I don't think I'd have a problem with that. Okay, so and I think there's more details about how long they spent on it, but this is just to bring attention that that's 3 projects that are working on a Lego sorting machine right now. So that obviously something's happened in the AI space, or in our industrial need or desire to sort Legos. So I don't think this will be the last one that we encounter anytime soon here. But I suggest you go check it out, read their story. But they did a lot in a short amount of time. And they have also what they learned, what they would do different about their project. Is some pretty good information in their project in there. All right, let's transition over to updates on our project. You ready for that, Amanda?
Sure. I have a little bit this week, not a whole ton, but so you guys see that? So this week, one of the big things that we did is we changed our vibrate channel. We did have a piece of sheet metal on there that was, we had it.
Oh, we just lost her. Nope. She said sometimes hits the wrong button on her webcam when she's on her phone, and she hits that disconnect button. Yep. Yeah, when switching view, she hits that wrong button. She'll be back in a minute. So Justin, I just want to say thank you so much for joining us in this video. I really have a high hope that your machine is ultra successful.
Sorry, I accidentally disappeared from the stream again. I pressed the back button. Yeah. Anyway, so we had a sheet metal vibrator, and it had several rivets running down the bottom where the pieces are, like to connect 2 pieces of sheet metal together to make that big of a V channel. Mm-hmm. So kind of the idea of our robot is we're processing a lot of Lego, so we have to have a lot of capacity, and also kind of like you had that carousel at the end of yours, we're planning to use air and like Chris said, have chutes that go into different bins. And this is because we have just so much Lego that we have to run through this machine that it would be impossible to have a big enough carousel to fit all of that, I think. So this week, one of the things that I did is I connected up our solenoid valves. You can see we have these manifolds that we got that have several solenoids connected together. And I connected all of the hoses to those, and I labeled all of the hoses with 1, 2. I went out to 24 because at the end where we have longer pieces going, I left every other hole empty. so that if a longer piece is on here, it wouldn't get blown off by the air next to it. But we can adjust that depending on how many categories of long pieces we have, or if we find that the spacing is just excessive or something. But for now, that's how I have it set up. Another thing that I did this week, I changed this setup here. So it used to be we had a ramp, a whole ramp assembly, and I got rid of that and replaced it with just a single piece of sheet metal because the ramp assembly was a little too big and it didn't really make sense the way it was. And also, I have this carousel turntable that spins the parts around. So this kind of helps make the robot take up less space. It already exceeds the length of the table that I'm working on, and I didn't want it to be just so big that we couldn't transport it or we couldn't store it in the shop on any kind of table. So the turntable helps make it so that we can have the vibrator going this way and the conveyor going the other way for that. But it also has the benefit of being a speedy second step after the vibrator. So if two parts are very close together, one part falls down, it will be gone very fast before the next part comes on. So that will help us get more spacing between our parts. So the carousel, of course, is a moving part with non-moving guide around it. So we can't have the moving part rubbing on the non-moving part. And we also can't have air gaps because, as we all know, there are Legos that are very small. So I used to have just a piece of felt that filled the gap between these. But this week when I was running a test, I found that the motor on the carousel was heating up to almost burn your hands. So I took the felt and I removed all of it and put new felt on and made a little brush that goes on top of the carousel instead of next to it on the side. So that seems to work a lot better, and it doesn't trap any parts that I've seen so far. So I'm pretty happy with that. And I would say finally I re-spliced the belt. We used to have, so one of the problems I was seeing is that our belt was getting stuck on different things underneath of here. So that was in large part because our splice previously was just this conveyor belt wrapped on top of itself. So there was a big hump here. So what I did was I took a piece of shaft and ran it through here and stitched each of the belts together, kind of like one of those alligator splicing clips that you might see on a conveyor belt at the grocery store. And this makes it so that the whole thing is level and you don't have to worry about that bump. Of course, if I had known that you could easily get a conveyor belt that is just perfect off of eBay, then I probably would have done that, because this was honestly kind of a waste of time if you could just get a pre-built one. But I also thought that we needed these cleats on here so that when you get spherical parts or wheels, that they wouldn't try to navigate around to different parts of the belt while it's moving, because where the part ends up getting sorted is entirely dependent on where it is on the belt. So you can't have them moving to different spots as the belt goes from the beginning to the end. So I'm considering taking the cleats off for the AI, because it's really just hard to differentiate between a part, like a white part, and a cleat. And it throws off your ability to just use thresholds to crop parts up. in OpenCV. I'm not sure if I have to do this, but like I kind of wish I didn't, because obviously if you do get a sphere and it does roll to the wrong spot, it's just going to get sorted wrong, and I don't like that. But for most of the parts, they just land on top of the cleats, so it doesn't like maintain spacing like I was kind of hoping it would.
So Justin, have you considered what you will do if a 1x1 round brick lands on its side and it starts to roll on your conveyor belt?
Yeah, we've thought a couple of yes, maybe pre-processing to eliminate rolling Legos up front, and then deal with those separately. So kind of focus on non-rolling parts first, because that is a legitimate concern, especially once you make a prediction and you're expecting a part to be in a certain location at a certain point. If it's rolling around, that makes it all difficult. So as part of our approach of taking care of the simple things first, just going to eliminate those up front and then come back and deal with them later on.
Okay. Yeah. Yeah, because I understand exactly what Amanda's talking about. We're going to have a ton of round bricks, so they're just going to roll one direction or the other, and they're not going to be where you expect them to be for the AI. That's definitely a huge challenge. I'm already spending an expense per pound to do a pre-sort, but it's starting to sound like there's two reasons to do a pre-sort to make the machine more effective. It's to get rid of those round parts that don't do what you expect them to do, or at least in these designs. And then the other challenge is going to be to separate all of the assemblies, because there are so many in the bulk that we get. Not everything is already separated, and there's no effort to do so the way we purchase it. It's going to have to be done in a pre-sort step. Interesting.
So we might be able to resolve the issue of the cleats in computer vision. I think that if cameras can be used to detect people walking down the street and they're not impacted by the blowing of the wind or the falling of snow, that surely there's a way that you can have a fairly simple background and you can tell when something is different on it. It's just that I haven't cracked the code of what that is.
Okay. Well, I think the cleats are a required thing for the rolling parts. It's going to have to be in the channel, and if it rolls one way or the other, at least it stays within the channel itself. I think the cleats are still a pretty solid idea, unless we try and we're going to have to eliminate every round part, because in Justin's design, he's already considered the fact that he has to remove all those round parts. I hadn't even thought of that until really this conversation, how that element would be handled differently. I noticed you had a 1x1 round plate, but the odds on that landing on its side are very, very rare, almost near impossible, in fact. But have you tried to sort round pieces, or you just knew that right off the bat that you wouldn't even be possible to sort in your assembly?
Round pieces would be part of that kind of pre-sort, and if it happened to fall on its edge, we would eliminate it up front. But I think even if you go back to the video, one of the two, I think it was a 2x2 piece, I noticed does land on its edge. Yep, you can see right there actually. So
Right,
it's not improbable for pieces to end up on their edge, which is fascinating. Is that a 2x2 or that's a?
That is a slope. It was a 45 slope.
But we have seen plates on their edges coming down the
really
the belt. So yeah, okay, that one is a slope, but we have seen plates like that coming off. So always surprises you.
So you probably are expecting to separate all your Lego before you put it into your hopper. So somebody's going to be doing that prior to. You don't plan on throwing any assemblies through it like I was thinking we'd be able to do.
Not at the moment. However, it would be you could accomplish separating any assemblies with AI. If it detects a chunk of Legos all connected to each other, just kind of toss those off to the side, and then come back and deal with those later. So
there's a comment in the chat here from Ironstein. It's what about a V-shaped cleats that force the piece into the bottom of a V? I don't know how you'd build I don't know how to do that.
I'm a little confuzzled by that too. If you had a big enough cleat that was like a container for a piece, then once you get out to the end where your roller is, it would look like that, and it would have to be peeled off on all but one point. So you can only have so big of a piece glued onto this conveyor before it just like breaks off of there when it goes around the pipe. So I think if I'm understanding correctly, you were proposing having a wider piece that's like V-shaped.
I don't know how you would do that. I like the idea that it has, but I'm not sure in practical terms how you would do that. We'll table that to try and do what we've got right now, because we're so far into our prototype that we kind of have to stick with what we've got right now. I don't want to have to go back 5 weeks and start with a new design at this point. And we'll see if we can get this one working. It was fully expected at the end of this project. This is a prototype. We need to learn as much of what doesn't work as what does work. Justin, do you have any idea on a delivery for your machine at this point in time?
At this point in time, when it's ready, it's ready. I think it's going to be our approach, and kind of continue releasing videos of that incremental progress into the community as it comes along.
You're welcome to participate in our Discord, and we are 100% open source. So any knowledge, any information, any AI that is developed inside of our Discord is free and available for you to use. And no expectation that what you develop as a proprietary system that you have to put in the Discord. Just come on in and share some knowledge with us, what you learned and what you're willing to give to us, and take from us whatever you can, because we're giving it away for free.
Awesome, yeah. And to that note, I think the mechanical part, we're playing around with open sourcing that, similar to, if anyone's familiar with the FarmBot project. And
I'm not familiar.
Basically, robotic farming platform, but it's all open source, and so you can either build it yourself, or they sell like kits with PCBs that are already put together, make it really easy. So maybe kind of a hybrid model between complete open source and offering some pre-built stuff as well.
So that would be like you buy this kit, go home and build it yourself, and then get a hold of your AI to run your machine. Is that what you were kind of thinking?
Something along those lines.
That's pretty cool idea.
The mechanical parts would be open source.
Yeah, one of the things that we've run into with our project and our design is that Amanda's got a pretty elaborate CAD, and she's doing this big design, not very accessible to the standard. I would not be able to build it with the skills that I currently have, but maybe in the model that you're talking about, it might be a little bit more accessible to somebody to actually build their own machine and then get a hold of some AI that's built for the way that machine is running. That's a really nice idea. I like that idea a lot.
Yeah.
Okay, cool. So that's it for today. Thank you, everybody, for participating in the chat, and good to see Art Engineer and Ironstein in there. And I'll reiterate what Art Engineer has said, that it's great to see multiple projects across the United States and all over the world working on these things. Was it Daniel West about 2 years ago got us all excited that this was going to be possible, and then kind of went cold. I'm not sure exactly what happened, but definitely showed us what was possible. And then I came to Amanda, and it was a different conversations, and she's like, we can do this on our own. We're going to do this. And I'm like, let's do it. So we're kind of like you, Justin. It's like whatever we get at the end of the summer is what we got. And if it works, it doesn't work, we're going to just take that knowledge and maybe try and improve on it. But the other encouraging thing is that the Discord has just grown and grown and grown, and people are adding themselves every week to come in and participate, share their ideas. Some people say, this isn't going to work, try this. There's people giving information to Amanda saying, you need to do an electronic vibration instead of the way you've been doing it with an offset weight, because this will be accomplished better. And then obviously you learned that and done it in your design. So constantly good information being shared. So any last comments, Justin, Amanda?
Nope, I think we're good.
Yeah, looking forward to keeping tabs on the projects.
Yeah. So yeah, definitely. I'm looking forward to your upcoming video on multiple levels of carousel. I have no idea what that would look like, but I'm excited to see what you're talking about. Justin, Amanda, thank you so much for joining me tonight. And this has been week 5 of the Big Robot. I'm Chris from the Great Brick Lab. If you are interested in joining the project, the scroll at the bottom has the information of where you can join our Discord and donate to the project as well. See y'all later.
Yep, thank you.
Bye.